Okay, guys, so today we're going to look at the first half of our 9.3 part 3. This is balancing chemical equations. I am going to break this lecture into 2 parts. I'll do the second part of this lecture tomorrow. So we're just going to go over the first 5 problems here. Okay. So step 1 is going to be to rewrite the equations on paper to balance them, which you might not have done, but it's worth doing so that you've got some space to work. And then we're going to fill in the blanks, and we're going to do the steps that we learned about before for how to balance these chemical equations. Okay, I'm going to work through these one at a time. So let me see. Okay. So problem number 1, we have 1N2 plus 2H2, and it yields 2NH3. This is the synthesis of ammonia. Sorry, my computer was acting up. This is a synthesis of ammonia. And so the first thing I do when I'm balancing these is I draw a little line here. And it helps me separate my problem into 2 parts. Okay. And on each side, I make sure I have the same number of atoms. Okay. So here I have 2N. So I'm going to say I've got 2 nitrogens over here. And then I have 2 times 3 hydrogens. So I have 6 hydrogens. Now, all I have to do is make sure I have the same number of nitrogens and hydrogens on both sides. So in my reactants, in my products, I have 2 nitrogen. In my reactants, I have 1 times 2, I have 2 nitrogens. And I need to make 6 hydrogens in my reactants. And so they come 2 at a time. So I'm going to divide 6 by 2. That's going to give me 3H2. Okay. That gives me 6 hydrogens on this side. For problem number 2, it's going to be a similar process. Use a different color here because that'll help us keep stuff straight. I'll draw my little line. And I'm just going to do an inventory. So over here I have 2 potassiums, 2 Ks. I have 2 chlorines, 2 Cls. And I have 2 times 3 oxygens. This 3 goes just with the oxygen here. So I have 6 oxygens. It's not a 0, that's an O. So on this side, I need to make sure that I have 2 potassiums. So this is the only molecule that has potassium in it. So I'm just going to do 2 molecules of this. So that gives me 2 potassiums. It also gives me 2 chlorines. Sorry about my handwriting. I'm trying to write really small, not touching the screen. And then I need 6 oxygens. And of course, oxygen comes 2 at a time. So then I need 3 pairs of oxygen. So 6 oxygen. Now they balance on both sides. I have the same atoms on both sides of my equation. Okay, so now we're going to move on to one that's a little tougher. I have 3 blanks in this one to fill in. Okay, so I can start just about anywhere, but since I went ahead and told you how many fluorines we have here, I'm going to start here. That's just going to be the easiest place to start. So I have 1 times 2 fluorines. 2 fluorines. So then I need to make 2 fluorines over here, which means there's no fluorine in this, so I need 2 of this molecule. I have 2 NaF now. That means I have 2 Na. 2 of those. So now I need 2 NAs over here. So let's go ahead and make 2 of this. Okay. Now I have 2 Na. And I also have 2 times the Cl. I have 2 Cls. So I need 2 chlorines on here. So now I need 2 chlorines over here, which means I need 1 pair of this. So hopefully in that problem, we can see how we sort of bounce back and forth. We go from here to here, and then we go from here to here, and then from here to here again, and then from here to here again. We're balancing back and forth. Like the pendulum of a pendulum clock. Okay. On this one, we're going to synthesize water. And on this problem, you'll notice we have 3 blanks, and that's it. Everything is blank. So this one's going to be a true guess and check. Are you able to see it on your screen? Yeah. Try to reload the page. Okay. So we're just going to just take a start, right? We can really guess anything. And so I'm just going to guess I'm going to make 4 H2Os. Okay, so I'm going to make 4 H2Os. So draw my little line here. This means I have 4 times 2, I have 8 hydrogens. 4 times O, I have 4 oxygens on this side. So I need to make 8 hydrogens over here. I need to make 4 oxygens over here. So to make 8 hydrogens, they come in pairs. So I'm going to have 4 of these. Okay. To make 4 oxygens, they come in pairs. I'm going to need 2 of these. Well, this is great. It is balanced. It is balanced, but it needs to be simplified. Okay. If 4 H2s and 2 O2s gives me 4 H2Os, then it's also going to be true that I can divide everything by 2 and it'll still be true. And so that'll be the simplest form of this chemical equation. So I have to start over. Instead of making 4 of these, we're going to make, let's say, 2 of these and see what happens. Okay. Erase all this and start over. So sometimes we have to try the problem twice so that it can't be simplified, so it can be as simple as possible. So 2H2O, that's going to give me 4 hydrogens. It's going to give me 2 oxygens. So if I want 2 oxygens over here, I need 1 pair of oxygens. If I want to make 4 hydrogens over here, I'm going to need 2 pairs of hydrogen. And look at that. It balances. I have 4 hydrogens. I have 2 oxygens. And it balances. And not only does it balance, it can't get simpler. I can't have less O2 here. Okay, I can't have less oxygen because I'm not allowed to change the subscript. The subscript has to be left alone. And so this is the correct answer for problem 4. 2H2 plus 1 O2 yields 2H2O. Okay. Now this last problem here, this is the most complicated yet. And it's probably going to be our model problem for balancing chemical equations, meaning this one's almost for sure going to show up on our test. I will ask you to do this. So to start out with, I'm going to draw my line, right? That's going to help me keep track of which elements I have on which side. And then I'm going to guess and check. So I could guess that I have 2 methanes, 2 CH4s. This is methane, by the way. Okay. Okay, sorry, I had to adjust something here. So I have 2 methanes, and that's going to give me 2 carbons over here. And it's going to give me 2 times 4, it's going to give me 8 hydrogens. So then I need to make 2 carbons over here. The only place I'm going to get carbon is in CO2, so I have 2 CO2s. I need to make 8 hydrogens over here. They come 2 at a time. So I'm going to have 4 H2Os. Okay. This is going to give me 2 times 2 oxygen. That's 4 oxygens. And then 4 times 1, that's going to give me 8 oxygens. And it's going to give me 8 hydrogens. So 2 methane. Oh, I'm sorry. I need to carry my oxygens back over. So I need 8 oxygens over here, which means 4 O2s. 8 oxygens. So 2 methane plus 4 oxygen will give me 2 carbon dioxides and 4 waters, 2 CO2s and 4 H2Os. This is balanced, but again, it needs to be simplified. And so basically, an easy way I can do this is I can look and say, what can I divide all of these by that will divide into all of these? And so that's going to be 2. I want to divide everything by 2. Okay, so I'm going to say I have one CH4 and two O2s and one CO2 and two H2Os. Okay, so when I balance this, all of these atoms, I'm going to have half as many. I'm going to have one carbon and four oxygen and four hydrogens, and four oxygens, four hydrogens, and one carbon. So I just simplified everything. I divided everything by 2. I divided it in half. So then I have one CO2 plus two O2 yields one CO2 plus two H2O. That's the balanced equation of the combustion of methane. Tomorrow, we will be going over the rest of, I need to clear that. Tomorrow, we will be going over the rest of these equations. Okay. They do get harder, but I think that today's lecture will help us to understand how to approach these. Okay. These are great practice problems for these. The decomposition of gasoline is about as complicated as we're going to get. So yeah, we'll get into that stuff tomorrow.